Okay, now we're going to look about how we use u substitution with definite integrals. And notice everything looks very similar in the formulas, just as indefinite integrals. But notice we have to change our limits. Okay, so your lower limit is going to be what you plug in. So this would be plug a into what your u was equal to. And here we'll plug b into u. And once you've done that, then you'll just evaluate that integral, that definite integral, like normal. Okay, so here we want to do the integral from 0 to 1 of x cubed times 1 plus x to the 4th cubed dx. Now we're going to let our u be the stuff that's inside the x cubed there, so it'd be 1 plus x to the 4th. So du is equal to 4x cubed dx. Now notice we don't have a 4x cubed, we just have x cubed. So we're going to divide both sides by 4 and we'd say 1/4 du is equal to x cubed dx. So we can do our substitution now. We would have 1/4 out in front and then u cubed du. Now, remember I said you have to change these lower limits. So we're going to take 0 and plug it in for u here. So this would be 1 plus 0 to the 4th, which is just 1. And then for 1 up here, we're going to plug 1 in there. So 1 plus 1 to the 4th. So this will be our integral 1/4 from 1 to 2 of u cubed du. And now we'll evaluate that. So 1/4. And then we'll integrate this. So u to the 4 over 4. And we're going to evaluate that plugging in 2 and then subtracting, plugging in 1. So we'll have 1/4. So we'll have 2 to the 4th over 4 minus 1 to the 4th over 4. Now 2 to the 4th is 16, so over 4 is 4 minus 1/4. Now we could distribute this, and 1/4 times 4 would be 1 minus 1/4 times 1/4 would be 1/16. So 1 minus 1/16 would be 15/16. Okay, so that would be the value for our integral. So notice, once you change the limits, you can do everything in terms of u. You no longer have to go back to x like you did with indefinite integrals. Okay, we're going to do one more here. So we have the integral from 2 to 4 of dx over 1 over x natural log of x squared. Oops, I have too many dx's here. We don't need this dx out at the end because we have the dx up top. Okay, now notice the natural log is being plugged into a squared. So we're going to let u be natural log of x. Well, now du is 1 over x dx, which could be written as dx over x. So we can do this substitution here. The dx over x becomes our du, and then we have over x, u squared. Now we're going to plug our 2 into our u, so that'll just be natural log of 2. Plug our 4 in, so natural log of 4. Now we can rewrite this just to help us see that we're going to use the power rule as u to the negative 2 du. So integrating this, we'd have u to the negative 1 divided by negative 1, which is the same as just putting a negative out in front. We're going to evaluate that at natural log of 4 and natural log of 2. So I'll have negative 1 over natural log of 4 minus 1 over natural log of 2. And you could get a decimal approximation, but that would be our integral.